Welcome, my dear student, in our math program for secondary 3. Dear student, today we are taking new lesson in static. What is the title? Moment of the force about a point in 3 dimensions. What do you mean 3 dimensions? X, Y, Z, I, J, K. The last lesson we studied the moment in 2 dimensions. What is the moment of 2 dimensions about a point? Equals, yes, R vector cross F vector. In 3 dimensions is the same 2 dimensions. By using 3 dimensions, X, Y, Z, I, J, K, the moment is changed. Dear student, look at the lesson of moment in 3 dimensions. The moment of a force about a point in 3 dimensions coordinate system. Dear student, look at the vector F equals Fi, Fg, Fk at the point A, X, Y, Z, which its position vector with respect to the origin point O, 0, 0, 0. Remember, dear student, we have force vector, we resolve it in 3 dimensions, I, J, K, and we have point A, X, Y, Z. What is the position vector R, X, Y, Z? Then moment of the force F about point O is equals what? X and student. Moment about point O equals R vector times cross F vector. Look at the figure. Moment about point O, OA represent R vector. R vector equals X, Y, Z. F vector equal Fx, Fy, Fz. By substitution in use determine to find R vector cross F vector. Why? Because we have 3 directions, X, Y, Z. We put I, J, K in first row in determine and coefficient of the R, X, Y, Z in second row, coefficient of F, Fi, Fg, Fk in third row. After that, we find the value. Look at example. Dear student, the force F 2I minus J plus 3K act at a point A negative 3, 1, 2. Find the moment of the F about point B 2 to negative 1. Then calculate the length of perpendicular from point B to line of the F vector. Solution. Dear student, in this case, we find the moment of the point about this point with 3 dimensions. We have the rule. What is the rule? R vector cross F vector. But in this case, we find R vector by 3 dimensions in X, Y, Z, I, J, K. Also, we have F in 3 coordinates. By using determine to find R vector cross F vector to find the moment of the point O. Look at the solution. When we find R vector equals BA vector, what is the rule of BA vector? Point A minus B point equals negative 5, negative 1, 3. This is R vector. Moment about point B equals R vector cross F vector. What is R vector? Negative 5, negative 1, 3. What is the F vector to negative 1, 3? By using determine. Dear student, look at the determinant contains 3 row and 3 column. What is the first row? I, j, k. What is the second row? Is coefficient of x or coefficient of y, z, and coefficient of the f. We find the moment equals 20i, 21j plus 7k. After that, we find the length of perpendicular. What is the rule? M over f. M is, yes, square root. What is the m? Magnitude of m. The moment equals 21j plus 7k. In this case, dear student, we find the magnitude or absolute of moment m by using square root 21 squared plus 7 squared. Also, we find the magnitude of f by using coefficient of force 2 power 2 plus 1 power 2 plus 3 power 2. After that, we find, yes, square root 21 squared plus 7 squared over square root 14. Answer is square root 37 length unit. Now we are translate to another example. Find the moment of f about the origin point where f negative 2i plus 3j plus 5k act as a point A, its position vector respect to the origin point I plus j plus k. Then find the length of the perpendicular from O or the origin point to the line of the force F. In this example, we use the rule. What is the rule of moment? R vector cross F vector. What is the R vector? Position vector of the point by 3 dimensions. And F vector, we have 3 dimensions, fx, fy, fz, by using 1, 1, 1 cross negative 2, 3, 5. By using determinant, we find ijk, the first row. Second row, we bought 1, 1, 1. Third row, we bought negative 2, 3, 5, coefficient of the force. Then answer is, look at the determinant. What is the determinant? Equals I multiply bracket 5 minus 3 minus j multiply bracket contains 5 plus 2 plus k multiply bracket contains 3 plus 2. I multiply determinant or square determinant, which cofactor of I, cofactor of I. I has cofactor, j has cofactor, k also has cofactor. Answer is 2i minus 7j plus 5k. After that, we find length of perpendicular by using the rule equals the moment over f. What is the moment? Magnitude of the moment. Square root 2 power 2 plus 7 power 2 plus 5 power 2 over the force coefficient of the f 2, 3, 5. We find the magnitude of the f by using square root 2 power 2 plus 3 power 2 plus 5 power 2. What is the answer? Square root 741 over 19 L unit. The coordinate components of the moment of a force about a point. Dear student, let F equals Fxi plus Fyj plus Fzk and position vector are xyz. What is the moment? The moment in this case we both determine has 3 row and 3 columns. The first row represent ijk and Second row represent x, y, z. Coordinate of position vector r. After that, third row represent fx, fy, fz to find or to determine, calculate the determinant to find the moment of point O. Components fx has no moment about x-axis where it's parallel. Components fy has moment about x-axis equals negative kx fy. Component, remember, component of fy has moment about x-axis. What is the moment? Negative kx fy. Or what is the meaning of kx? Is the position vector or one of the coordinate of the position vector kx. Why negative? Because with clockwise the sign. The third component fz has moment about x-axis equals jx fz. Then the moment equals y fz minus z fz, and the same in the direction yk. Example. Dear student, we have force ki plus 4j minus k. This force acts at a point A whose position vector with respect to origin point is 1, 2, 2. Component of the moment of F about y-axis, its value 7 moment unit. And the length of perpendicular from the origin point O to the line of the force F. Look at the solution. F equals, we have 2, 3 coordinates in 3 dimensions. F vector equal k for negative 1. Position vector R equals 1, 2, 2. Moments component about y equals z fx minus x fz by substitution. Therefore, answer is 2k minus 1 times negative 1 equals 7. In this case, 2k equals 6. Therefore, k equals 3. Moment. We both determine of 3 row and 3 column. The first row ijk, second row coordinates of position vector r 1, 2, 2. Third row coefficient of the force 3, 4, negative 1. By using determine solution, we find moment at a point O or the origin point equals what? Negative 10i plus 7j minus 7k. Why? Each ijk has cofactor square. What is the determinant or the square determinant of I? 2, 2, 4, negative 1. By using 2 times negative 1 minus 2 times 4 equals negative 10 in I vector. What is the cofactor of j? Yes, look at j. J, we find cofactor or determinant, square determinant 1, 2, 3, negative 1. 1 times negative 1 equals negative 1 minus 2 times 3 equals negative 6 equal 7j. After that, k, what is the square determinant of k? K lies in first row, third column. Then The square determinant 1, 2, 3, 4. What is the value? 1 times 4, 4. 2 times 3 equals 6. 4 minus 6 equals what? Equals, yes, negative 2. Remember, dear student, I, G, K, I positive, G negative, K is positive. After that, we find the length of perpendicular by using the rule. What is the length of perpendicular? Yes, moment over F. What is the moment? The magnitudes of moment by using square root 10 power 2 plus 7 power 2 plus 2 power 2. 100 plus 49 plus 4, this is the magnitude of the moment, equals 3 root 442 over 26. This is L unit. Now we are translate to another example. If we have F equals Ki plus Mj minus 2k acts at A, its position vector respect to the origin point R vector 3, 1, 1. If the two components of the moments of the force about x-axis are negative 1, negative 8 respectively, find each of k and m. Look at, dear student, we have IJK. We find the moment IJK 2, 1, 1, km negative 2. 2, 1, 1 is the position vector of R 2, 1, 1. Km negative 2, coordinates of the force. Look at negative 2, negative 1 is the moment or component of x, 1. Then in this case, you find negative 2 minus m equals 1 by substitution, or find m equals, in this case, negative 1. By the same method, 3 times negative 2 component of fz of times negative 2 minus 1 times k equals negative 8. In this case, we find value of k, 3 times negative 2, negative 6, negative 6, negative k equal negative 8. Then answer is k equals 2. Remember, m equals negative 1, k equals 2. By using or substitution about k equal negative 1 and k equals 2 in determinant, we find the moment of the origin point. Now we are translate to another example. Look at, dear student, we have two forces, F1, its value 6 root 13 Newton, F2 act in AB, F2 equals square root 61 Newton, act in AC. Look at, dear student, we have 3 dimensions, OX, in the opposite figure, OX, OY, OZ. ABC, look at triangle ABC, AB, F1 act, F2 acts as a point A. Look, the direction AB and AC in the figure. Find the sum of moment of the forces about O. We have two forces, F1 and F2. Find the sum of moment of the forces about O. Number 2 or number B, find the moment of the resultant about O. What you deduce? from the geometrical of the figure, look at point A 0, 0, 6. Why? Because coordinate of x 0, y 0, but z equals 6. What is the value of z? Look at 6 meter is the intercepted from z axis. Point B, look at 0, 4, 0. We have coordinate of V. 0 from the figure. Point B, 0 in x, 4 in y, 0 in z. Point C, look at, we have 4 in x, negative 3 in y, 0 in z. We find the vector AB by substitution B minus A, point B minus point A equals 0, 4, negative 6. After that, we find AB norm equals 36 plus 16 under square root equals square root 42 equals 2 root 13. What is the F1 moment? F1 vector, F1 cross AB vector star. What do you mean AB vector star? AB vector star means AB vector over norm AB. What is the value? F1 6 times root 13 times norm AB, AB over norm AB equals AB vector equals 0, 4, negative 6 over this vector over norm of at square root 16 plus 36. In this case, F1 equals 6 root 13 cross 0, 4, negative 6 over 2 root 13. Then answer is 0, 12, negative 18. F1 equals 3 AB. AC, we find C minus A. We find AC vector, C minus A vector. What is the C? 0.4, negative 3, 0. What is the A? 0, 0, 6. By subtract, AC vector becomes 4, negative 3, negative 6. F2 equals, by the same method, F2 times AC vector over AC vector. F2 equals what? Square root 61. AC vector 4, negative 3, negative 6 over norm of AC by using square root 4 squared plus negative 3 squared plus negative 6 squared equals square root 16 plus 9 plus 36. Therefore, answer is 4, negative 3, negative 6. Moment F1 about O equals OA vector or R vector cross F1 vector. What is the OA vector? 0, 0, 6 cross F1 vector 0, 12, negative 18. By using determine, we have determine formed from 3 rows. The first row IJK, second row the point O 0, 0, 6, third row coordinates of F1 0, 12, negative 18 by using solution of the determinant to find the value of moment F1 about point O or OA vector cross F1 vector equals negative 72 I vector. Moment F2 about O equals OA cross F2. By the same method, OA vector equals what? 0, 0, 6 cross 4, negative 3, negative 6. By using the determinant IJK in the first row, 0, 0, 6, second row, 4, negative 3, negative 6, third row, equals negative 6. Why? We have in the second, by using the second row, 0, 0, 6, we take negative 6 multiplied cofactor of the square determinant equal negative 18i plus 24g. Sum of moment about O equals F1 plus F2 plus F3, negative 72i plus 18i plus 24g. Look at 72, negative 72i plus 18i equals negative 54i plus 24g. Then sum of moment of a point O. Resultant of F equals F1 plus F2. We add F1 plus F2. We find at 4, 9, negative 24 at the point A. Moment of the resultant equal OA vector cross F2 vector. 0, 0, 6 coordinate of OA cross 4, 9, negative 24 coordinate of F2. By using the determinant contains 3 rows, 3 column, IJK, 0, 0, 6, 4, 9, negative 24. By using this second row, negative 6 times cross times 9i, negative 4j inside bracket equals negative 54i plus 24j. What you deduce? Yes, sum of all forces, moment of the two forces equal moment of the resultant, negative 54i plus 24j. Remark, dear student, the sum moment of the forces about a point in the space equals the moment of their resultant about the same point. This is the theorem. It's very important. When we find sum of 2 or 3 or more forces about one point equals the moment of their about the same point. Now we are to translate to another example. Look at, if we have F1 2i plus 3j minus k act at a point A 1, negative 1, 4. Find the moment about O 0, 0, moment about B 2, negative 3, 1, and length of perpendicular from B to the line of the force F. By using the moment about O, we put determinant IJK first. We put R vector OA vector 1, negative 1, 4, 2, 3, negative 1. This coordinate of the force. Answer is negative 1, negative 12i plus negative 1, negative 8 inside bracket negative j plus 3 plus 2 inside bracket times k. Answer is negative 11i plus 9j plus 5k. R2 equals BA. We subtract A minus B. Answer is negative 1, 2, 3. Moment B equals by the same method. IJK negative 1, 2, negative 1, 2, 3. Second row, third row, 2, 3, negative 1. By using the same determinant to find the moment of about point B, negative 11i plus 5j, negative 7k. What is the length? The length equals, yes, square root 121 plus 25 plus 49 over square root 491, or 2 power 2 plus 3 power 2 plus 1 power 2 equals square root 195 over square root 14 equals 3.7 unit. Dear student, by the end of the lesson, we know moment of 3 dimensions. Remember, very important lesson, moment of 3 dimensions in our life, very important lesson. I am very happy to spend such time with you. Goodbye.